So I'm very pleased to introduce you to Marek Volosin, our speaker today. If you have any question, a small reminder, please use the Q&A panel for the questions, and after the lecture, the speaker will answer your questions. So, Marek, the floor is yours.
Okay, thank you very much. So, my name is Marek Volosin. I work in GlobalLogic as a senior software engineer. So today I will share my screen. So, can you see my screen?
Yes.
Okay, so today I was asked to tell something about locally running large language models and some practical exercises. So today I will show you some offline running large language model, some chatbot that can run on your notebook, and you can chat with it without connection to the internet. So we will go through some installation steps and some next possibilities with such offline language models. In practical part, we will try some Python scripting on a web page, exactly on Google Collaboratory servers in web application. So I can start with my demo. So little theory in why I decide to try such activities. Many companies are not using chatbots inside the company because of privacy concerns. Many employees can use chatbots for work, and the chatbots are from outside of the company, and the data which are using, that people can go outside the company, and it can be compromised. So companies are prohibited the people to use chatbots for private activities with company data. So we need using chatbots in our work. We can use it, for example, for some internal presentation, for some projects in company, etc. But it's not possible with public chatbots. So there are some possibilities how to install large language models on or on your own notebook, which is possible to use without compromising the company data. So this is my motivation how to use privately running chatbots. To run such large language models on a small notebook, this can be a very big problem because the operational memory in a notebook is small. Very often notebooks have no video RAM memory, And large language models are known that they need huge amounts of RAM and video RAM memory, mainly video RAM memory. On this picture, you can see that such big models as which has 70 billion parameters needs at least 32 gigabytes of memory, but there are much bigger language models on the internet, 150 billion parameters, 500 billion parameters, etc. So such big models are can be used only on big data centers. And second thing is that so on a notebook we can use only small versions of that large language models, because some language models is in more versions. Smaller versions of the same large language model can have only 7 billion parameters or 13 billion parameters, etc. So on a notebook we need to use only small versions of the language models. And the next thing is that we need to use quantization methods to make much smaller that language models. Quantization means that large language model you can imagine like a very big table of numbers, and that numbers are in floating point format. So very big tables, 500 billion numbers in one very big table. And when you change that floating point numbers into integers, so without integers, and that can mainly the integers in computers are represented as 32 bytes of memory for one integer, but we can use much smaller integers, for example 16 bytes integers, or 8 bytes integers, or 4 bytes integers, and some scientists try to make smaller that language models, and they realize that integer version of the same language model is has very similar responses, high quality responses, and the size of that language model is much smaller. So we use some very small versions of that models, for example 7 billion parameter model, and only 4-bit integers used. In this image you can see that difference between floating point 32 byte number and integer 8-byte number. Here is memory consumption of that floating point number, and the memory consumption only 8-byte number. So is a big difference if you have 70 billion such numbers or only 7 billion numbers. So we need to reduce the size of the language model to fit it into small notebook RAM memory. So on on the internet, this is old, maybe a half year old approach, how to run a language model on a notebook. There is some better approaches. I can show it shortly. So here you can on this web link you can download software from this website. It's such web application with some user interface into which you can download, you can load the language model and run it. So from this web page, I will download the installer, where it is. In a zip folder, I save it. I have it on my disk, so I will show you where it is. So here I have these files from zip extracted from zip file, and I will start installation process. I need to switch to Python 3.11 version, and I will start with a very simple command. Installation process. I have this software installed before this webinar, so my software will run. The same command is used for installation and for running the web application. So it starts shortly. It's a web application, some web graphical user interface to which is better than command prompt and text user interface. So this software is only a graphical user interface and some helper software to run a language model. Because language model is some big table. I imagine it like a big table of parameters, so only data. So on this web address, which is my local address, is running now the graphical user interface, and here I need to download some language model, and I use Hugging Face web server. With this is a language model which I will be using here. I need to copy this path. The block is the Llama. Second is language model from Facebook, from Meta Quest, from Meta company, and the block is somebody who is quantized that model and make better use for local run. Okay, so this path is very important. I copy it with this, click on this button, and let's see. Okay. So here I paste. Here I paste the this path and try to download it, and it's downloading to my hard disk. So it's it takes some time, but I have this in this folder. I have downloaded that files. Here is the 1, 2, 3, 4, 5, 6, 7, 12 versions of language model. Every file is one version of language model. As you can see here, files. Here is that the same files, and you can see it's a model. GGUF means a quantization method. And with here is some information about that language model, and you can see that every version of that model has some quality loss because of changing its size. So this 8-bit integer numbers quantized model is very large, and quality loss is small, but the running on the notebook is slow. So we can use the best quantized and smallest model. It's only 2 bits integers, so there is significant quality loss, but it's smallest. So the answers from this chatbot will be very quick, but very low quality. So so not very good very bad answers. So here is recommended quality and size of that language model. It's 4-bit quantized language model. So this I will use in my demo. So here this files was downloaded. I have it there. You can see this is in my web folder. Every file is several gigabytes of memory in a hard disk. So the downloading process is lengthy. So I have downloaded before the webinar, and I will run it. I have to choose it here. I choose this recommended version of the language model. I can use four threads because my CPU processor on notebook has 4 cores. So I use four threads to run this model and load it. Okay, it's loading, and it's successfully loaded, and it's Llama version 2 model. Now I can chat with this model because it's running in my memory on a notebook. So I will ask some questions. You can write some questions into chat. I can write that questions here. For example, And my notebook is presenting video stream, so will be a little bit slower. And you can see the answer is coming. And you can see that answer is composed word by word. So not all answer is at once, but every word is created sequentially. It's a standard work of language models, transformers, neural networks.
Marek, we have a question. If you can
Okay.
duplicate links from presentation to chat so
Okay.
that they can repeat your steps.
Okay. So this presentation will be available, I hope.
The recording will be available.
Okay, I will share my disk, Google disk, and you can download all files from this webinar to you. So please.
Maybe now just share the link that they can follow your steps.
I need to, yes, okay. So here is a link to my shared folder. Here is link to graphical user interface for that language models, but it's little old technology. Much better now is Olama technology. I will show it shortly. So this is a little older. So you don't need to use this how to say, you don't need to use this approach. You can use you can download software from Olama. It's very simple. Download for Windows or for Linux or for macOS. You can choose where to installer to save. I have installed the Olama already on my computer, and I can show you how is Olama fast and quick. So I have running Olama in my in my memory. I will stop this. I will stop this this software. Okay, this is stopped. And the second approach, this is new. I get the information about Olama 2 days ago. So but it's very quick and very high quality answers from this. And it's Llama third language model, so is much better optimized for using on small laptops or such hardware. So I will run it, and it has only text user interface, but it's it's not problem. So I will try ask the same question. You can see the response is very quick and will be very long because length of the answer is very very important. Small models has small context, cannot small memory is constrained to have a big to take big context. The computer needs to remember the topic about which is the conversation, and the topic means the context. And if that context is very short, with small RAM memory, the answers will be short and not connecting one to another answer. So you see that this answer from Llama 3, Llama 3 language model is much better. This is language model 2 from Meta, from Facebook, machine learning engineers, but it's much better. You can see it's very quick and very good. You can ask anything with switch. You can switch off internet, go somewhere on a boat or on somewhere in a forest, and you can ask anything this language model, and chatting and learning some things about anything. So I can see here some questions.
Yes, we have questions also on in Q&A. So maybe you can answer also now, not at the end, but because there are
this is
questions
first this is first part of presentation, so I can ask, I can respond to questions now, and then will be some practical part. So we will be chatting with participant. So you can see the answer is very long. So Ollama.com is the website. The installation process is very easy. Anybody install it very easy, and this command is important because of choosing which model you want to use. And you can see it's 8 billion parameters model with quantized to 5 bits integers, I think. So I will try to answer the questions.
You can see the Q&A?
I don't see it. Excuse me. Yes, I can see it. Okay, so NVIDIA has much better GPU processors. My notebook has no GPU processor. I have no dedicated graphic cards, and you can see that answers are very quick. So I can recommend you the second approach, Ollama.com, and that approach, which is in a presentation, is old half a year. So this technology is very quickly progressing, and the changes are every month. There are new things. So please use that newer version of. And there are some other approaches how to run locally, because big companies which are creating large language models are creating versions for local running their models, because users want it. 1 year ago, too few people want to run it on a notebook, but now many people want it, and big companies are creating language models optimized for such use, for run it locally. Okay. So the first question, NVIDIA GPUs are much better, I think, but you don't need to use it to buy the NVIDIA graphic cards. But if you have NVIDIA graphic cards with large GPU, large video RAM, you can install much bigger language model, and you will have much better answers. But you can see here that answers are very good. No problem with such small model. I will try to ask something else. For example, something from physics. And you can ask anything in a wood, in a forest somewhere, or in submarine. It's no internet needed. It's perfect. You have to try it. Okay. So next question. How to find language model, the Hugging Face web page. I will Hugging page here. Hugging Face. Here is the web link exactly to this language model, but it's Llama 2nd, and it's not such good as Llama 3. Third. Okay. I will sometimes it stops answering. Maybe I will need to restart it. So I will answer next questions. What do you think about the relatively recently released NVIDIA Chat-RTX? And NVIDIA has very good technology, and I don't know exactly what is Chat-RTX, but I remember something about NVIDIA has the similar software which you can download and run the language models. And if you have NVIDIA card, you can download that software and if you have very good NVIDIA card, the language model will be you can run big language model, big version of language model, and your answers will be much higher quality. So so it's very good to buy NVIDIA graphic cards and use that software from NVIDIA. I can recommend it. But you can see that I have notebook work from work without graphic cards, and the technology is very good on this slow hardware too. So you can see how long will be the answer about quantum physics and quantum mechanics, and you can answer from any kind of knowledge. And Llama 3 has some 2021 knowledge until 2021 December or such. Okay, so I can recommend you the can recommend that chat RTX. Okay. Next question: why does the chat print the text so slowly? Doesn't it have it already ahead? The response from the language model is generated sequentially. So every word is generated after another. If you run ChatGPT on cloud, the answer is at once send it to you. So you didn't see that slow response, one word after another, but this my computer is very slow, and here I have no filters. ChatGPT and other online web service that web services with language models are using many filters for inputs, for prompts, and many filters for output for security, and using some words, etc. So this is pure answer from the language model. Such one word after another. The transformers works this way. Okay, this is the question. The next question: Llama is needed just to run Llama models. What are the benefits of using it instead of common instruments like Torch? Okay, so Llama is not only for Llama models. You can see here. You can see here not only Llama but Phi from Microsoft and Mistral from French company. This is the best models to run locally. The best, the smallest, and the quickest, and the best answers, high quality answers models. So you can see you can run any from these models. So not only Llama. Okay, so this is answer for your question. Next question: when we have downloaded a large language model to our laptop, do we still need an internet connection to work with it, or does it already contain the entire knowledge base and we can work with it offline? Yes, I said it, that you can take your notebook with that language model downloaded and run it in a bus station or somewhere in a forest or in submarine. It's no problem, and that knowledge is inside the language model. It's perfect. It's unbelievable that I can show you the answer from quantum mechanics. You can see it's not stopping. and it's not telling lies or wrong answer. It's good answer, and still answering. So Llama 3 is very good. Okay, next question. So offline language models does not use access internet after training. Do online language models use internet access to improve their answers, or they are self-sufficient too? I think that technology behind servers is much more complicated than this. As you can see, there are many filters. For example, OpenAI is taking the questions and answers from the users and make better their models. I think that OpenAI is using their free service to get data from the users, new training data. So online services are used for getting data, new training data, and they will train the models and make them better with the data. And offline language model, offline run language model don't use internet. So perfect. And of course, large language model with 500 billion of parameters are running without internet too, but you need big data center to run it, very big video RAM memory. So maybe 100 gigabytes or 500 gigabytes memory. The big GPU farm for such big model and such many users, because now I am only one user for this language model. But if you have there 100,000 users asking the questions at once, that language model need many big memory and very strong GPUs to answer for all users. So, okay. Next question: what exactly is fine-tuning a model and training, and what is the best approach of doing it? I will continue my web presentation shortly, and you will see there. Next question: is there a language model to download on my computer that will search the info on the internet? I think no, because language model is neural network, transformer with transformer architecture, and is trained, and no new information is taking from internet or from any place. But there is some approaches how to make better answers with PDF documents, and you can add data to language model and not train it again, but shortly. So you can see that answer is huge, and if you know something about quantum mechanics, you can check it if it's good. So I will take the last slides from the first part of the presentation. So large language models we need to tune because their knowledge is about general topics, and they are good. They are trained for conversation and not for some special topics. For example, some some special languages or only in English and not other languages. So different companies make different language models, and that language models can be good in one use and not such good in other type of tasks. So we need to take to training of the language models is very costly. You need is very computationally expensive. And it means that you need a big data center, and you need money to pay for the training, and it's millions of dollars. So we are searching the ways how to not train again that language model, but only fine tune it, and fine tune it in a way which we don't need such big computational power. And here you can see four different approaches how to make better answer for your specific task. For example, you need answer only from medicine for taking care about patients, and not about physics, not about politics, and nothing else. You need only one. You need very good answers only with one topic, or you need only specific answer, for example, in XML format, or you need JSON format answers, and no conversational language model, but JSON answers or source code answers. No conversation. So that language model is trained for general use, and you need to fine tune it for your task. And for example, prompt engineering is one. Excuse me. Prompt engineering is very easy way how to make better answers for your task. You can write special prompts which will make the answers better fit to your needs. Second, very often used approach is retrieval augmented generation. You can use PDF documents or YouTube videos or text documents or web pages to enhance the answers of the language model. Because, for example, that Llama 3 language model is trained only with information until 2021, and older, newer technology, newer information is not there. So you can download some PDF documents with latest information from politics or from some the latest technology, latest knowledge, and you can insert that information to your prompt with such technique. So this RAG fine-tuning method is very often used and is very good. You can check it on. Here is not time for the details, but it's very good technique. You can use YouTube videos, and you can chat with that YouTuber about that topic from that video with your language model. So, or you can download big PDF document from Java or from economics and chat with Chatbot about that technology, what was in that PDF document. So it's very good technique, very often used. Parameter efficient fine-tuning, like LoRa, is a technique which is changing only small numbers of parameters. For example, a large language model has 70 billion parameters, and with LoRa technique, you take only 500,000 parameters and change that parameters and not all language model train. So you don't need to pay big so much cost to GPU computational power for retrain the model. And full fine tuning is tuning or whole language model again with specific data which you need to learn. So this is some overview of the fine-tuning methods. You can check it on internet. It's very important because of cost savings. We don't we cannot retrain all the model because it's very costly. Okay, conclusion. This presentation was about locally running language models because of security of your data. Your questions are not going anywhere. Is staying in your computer. No company is tracking you, and you can use that language model to create your content for your company without afraid of some data data break. It can go somewhere from your company. So we need locally running for security reason. We need locally running language models and language models that are running on company computers in data centers, in company data centers, and you can use it for your knowledge, for your learning. You can use it for assistance. You can create text for your work, etc. So it's very good technology. So I think that the time is we can progress to next part. If I can answer some questions, but very quickly. How trained language models are ranked compared to decide which one is better? There are some comparisons between language models. Every model can be very good in one tasks, but be not such good in other tasks. So there are comparisons, and the best models are often very known with audience. So you can check the comparison of that language models. Every language model is different. Next question: Are these answers generally reliable? Would the information on general questions more or less correspond to what I would find in textbook or other reference sources, as though the model has read them and rephrased the information for me? So these answers from small models is more faulty because that model is small, but the technology is progressing very fast, and the companies are focusing on making very good models with small sizes. So you can see the difference between Llama 2 and Llama 3 answers. The difference is very huge. So it's only half year or 1 year later after Llama 2 when it was available. So the technology is very fast progressing, and the answers will be much better, and our hardware will be much powerful because NVIDIA is working very intensively on new GPUs, and notebook with GPUs I think will be much often used from this day in future. Next question. So that answers are very good. As I chat with that Olama, that answer was very good. And of course you cannot believe that answer. You always need to check it, but there is no time to check every answer. So generally there is recommendation to check the answers, but you need something to know about that topic. You don't you need have some answer are very good. Very few errors are there, and it will be much better in a half year or 1 year ago. It will be much better. So now is very good, and it will be much better. And next question. Have you heard anything about analog neural network training chips from the company Mythic AI? Of course, neural network can be implemented in many ways, and if it will be working, it will be good. If it will be cheaper to produce and cheaper to run, in this if that Mythic AI company will have very good results, they will get big money from investors, and their technology will progress very quickly. So it depends on their results, and investors will be investing in this technology, and this will be very quickly expanded if it is a good approach. Maybe there could be some problems with making bigger neural networks, for example, or there can be some complicated technological problems, and they need to be resolved to get bigger neural networks, because as you can see, the size of the neural network is very important here. So that's my answer for this, and I can check the chat, or we can proceed to next part.
I think we can go to next part. There
Okay.
is no questions
Okay.
in the chat.
So the practical part, I will. Here is my Google Drive. You can try to click on that link and tell me if you can access that. Where it is? Excuse me. Here is my Google Drive. And here is some files, and I will upload there this presentation. Okay, so there is a presentation, and you can find there all web links. Olama is not there because this is a new thing for me, so it's not in the presentation. Okay, so for practical part, I prepared some text. We can create the practical part is about Python scripting. I don't know if you know how to code in Python, but if you want to, this webinar is about AI and artificial intelligence. So if you want to make something with artificial intelligence, you need to know Python language because it's very often used everywhere, and every examples are in Python language. So you need to learn Python. Okay, if you know Python, then you can learn Python with very special technology, which is this. No, I can show you it different way. I create here one special document. It special document which has special type. Excuse me. Type of this document is ipynb. It's a Python notebook abbreviation, and you can download it and give it to your disk. So this is classical document like Word document or Excel documents. This is other type of document which has Jupyter source file, and you can see this is Jupyter notebook document, like Word document or Excel document. And this is special type of document. I can write here some text. For example, here, excuse me. So, like a Word document, I will write some text. For example, this webinar is about AI school. I can make I can make bigger font. Okay. This document is about our AI webinar. Okay, so this is uh, this is a document like what, but the special thing here is that you can here write Python code. For example, and you can run that Python code inside the document. So imagine that you have a Word document where you can insert tables, images, web links, make formatted text, etc. But you can run Python code inside, and that Python code can be very simple, like here, like this, but it can be little more complicated. For example, can be like calculator. I run this code. You can see the next year will be 2025. So you have Word document with calculator inside, but not only calculations, but you can have there more complicated scripts. For example, you can give here some data. Okay, so now I will insert new chapter. Okay, and I will mix it with Python code. And this code is making a graph of 4 numbers, 1, 2, 3, 4 numbers, and you can see that the graph is very easy. On x axis there is, I can change that numbers, for example, and run it again. You can see that this code is okay, is running. So you can mix the text with the code. And if you make some scientific paper, or you need to explain somebody something about Python scripts, something about mathematics, or something about data, about data science, you can use this type of documents. I can show you more complicated. Okay. Excuse me. Okay, so here is text. And here I have here very nice script from data science. This code is taking package, a Python package with sample data, and then from that data package is taking data, example training data from stocks market, and it will be creating chart with lines about stocks, about stock prices. And these data are real data from the stock market. You can see that it's from 2000 to 2010 data, and it's some stocks from Apple, Amazon, Google, IBM, Microsoft. And the special thing is that you can move that graph. It's interactive graph, so you can take close look at some parts of that. So this is more complicated result from that Python code. And we have here much more complicated things. For example, here I have here I give a web link to other such very similar document where is machine learning Python script. So we can go to much more complicated Python scripts inside text documents. So you can see here is text. This formatted text very nicely, and now and here is Python code. I can run this code and import that libraries. And very important thing here is that that Python code needs to run somewhere, and if you coding with Python in your computer, your CPU is running that Python code. But here we are on a web page. You can see we are on a Google.com server, and here is Colab work. We are on Google Colab web servers, and it's some web application that is presenting us for us this technology, how to create such documents, Jupyter notebooks documents. And this Google Colab has very strong. Google servers are very strong and very cheap, and you can look here what machine is running our code, and you can see that we here very good machine with big hard disk and big RAM memory, and we can change the CPU processor for machine learning. Okay, we can change CPU for machine learning for much better computational power with the GPU, and it's with no cost. This is my free mail Gmail account. You can see this is my working account, and here is my standard free Google account. So you can see as a practical part, you can see you can start your Gmail, and with your Gmail, excuse me, excuse me, here, um, so you can start your Gmail and log into your account, Gmail account, and then write, or I will share with you this web link. And you can, if you have Google Gmail, you have access to this very strong Google servers. So not much people know about it, but you have free computational power from Google. Everybody has such possibility to write machine learning code on GPUs with no money needed for this. This is a very unique possibility to make machine learning on such strong machines. And you can see here is 15 gigabytes of RAM memory, and my notebook has 0. And our working notebooks are very good and not such cheap, but we have 0 GPU RAM, but here is GPU RAM for no cost. So it's very good service from the Google. Perfect. So I switch that you can start the Google Colab. You need to go inside your Gmail account, and then you can start Google Colab. You can see that I am here in Google Colab, and my Gmail account is here. So I need to be logged in my Gmail account. So you can start Google Colab and try to switch to CPU power to change runtime type to GPU processors. And I will here on shared folder. Here is car price prediction. It's from data science, data analysis, and machine learning with some data. So I run that Python code again. This is importing some libraries from Python. Now I need data not from a package, but from this file. Here I have in this text file I have data for my data analysis. So I need to connect to my Google Drive. So I am working on Google Cloud. I have files on a Google disk, and I'm using Google servers for computational power. So I need to connect to my Google disk. Where is my file? Okay, and I try to read. Here is the data set. So this is text document, comma separated value, text document with data for my machine learning and data analysis. It's on a shared disk. You can see it here, and I connected from Google Colab to my Google disk, so I can now see my Google Drive here, and here is my shared shared Google Drive, which you can access, and here is that data set, this file I need to download to my script. Okay, I run this script. So here I have successfully uploaded that data from the text file to this variable. It's data frame variable from Python data data analysis package. So in this small variable, I have all the data from that text file, and I can make analysis on the data. So here is I search all zeros. I think I can plot some graphs about my data. So this is data from that big table, and you can see that that table is has many columns, and I can make here some analysis with no coding, because this Google Colab is and Python and that Jupyter Notebook technology is helping me to analyze the data. Okay, so here is some graphs about the data, and these graphs, for example, are about in x axis we have a wheelbase for it's data about cars. You can see that cars, every car has some need to do it again. Every car has a name, type of fuel, number of the doors, where is engine, in front or back, etc. So every car is has some attributes, and this is data for me, and I want to predict the price, because this price is from cars has such price, but if I have some car without price, I can predict its price with comparison to all this data. So I will have some car Audi, which has not gas but other. It can have some differences, small differences, but the machine learning script will predict me a very good price, helping me to make price for that car without. So about this is all the script. Here is some analysis of for example here bigger horsepower cars has bigger price. So very small engines is very cheap, but very strong engines are with high price. Of course, if it's all car, the price is not such big, but overall, how bigger is the engine, the bigger is the price. So you can see the correlation here between horsepower and the price. So this is some analysis from that data about cars. And next script I run. We are removing some columns from this data because we don't need everything. We want only predict the price of the not known car. Okay, that we need to normalize. We need to normalize the data. Data normalization means I don't want to talk too much because time is going and we want to have some practical part. And this I run it. The script is good and is this it trains on the data machine learning, linear regression. Linear regression model is created, and if I evaluate, I can make evaluation. So here is I created some data, some predictions with test data. Testing data has removed a column with the price, and I test my model what price is predicting, and then I compare the removed data with the predicted data. And you can see that my model is predicting the price with 84% success to data which was removed. So you have table. You divide it to two parts. One part will be training for that machine learning model, and second part will be for the testing. And from the second part, you remove the column with the price of the car, and you train your model on the first part of the data, and then you run your model and try to fill in the last column with the price. Then model will give there some numbers, and then you compare the numbers from the model with the prices that you removed from the data, and the success or with that comparison you get the score. If there was very similar prices, the score is high. If there was not similar but very different prices, the score will be very low. And this score is 84%, so it's really good, really good. That model fits really good for this data. So it's simple machine learning data analysis task, and all is make only in Python script on Google servers on the web page. You can download it with one click as a file. You can insert it in your Google disk and run it with one click. You can run this. You can run this script. Where it is here. You can run this script on Google Colab and run it, play with the data, etc. It's perfect technology. So Google Colab and Jupyter scripts are very, very intensively used in machine learning with Python. So we can proceed to some practical exercises. I create here some very easy steps.
But
So
I think, Marek, that we should make it a bit quicker because we are running out of time already.
Okay.
So just maybe
Okay,
one
this is
example.
finished. This is finished. So this is the last part of the presentation or the webinar. No. Excuse me. So here is some exercises for you. You can yes. So first exercise for you is take the Python this file uh, this Python this document is about Python commands. And if you want make machine learning, you need to know Python. And this document is very nice, very nicely showing you the basic commands Python. So you can run this, and you can run these simple commands in your Google Colab account. So how to write comments, how to make some simple mathematics, make some true and false logic, etc. So please start your Gmail account, download this Python document. You don't need to download it. Only to click on that document and run it. It runs on your Google Colab. So please try to make it, and write me some questions or problems what you have. So these exercises are very, very easy. Only to run that prepared files and try to run some scripts inside that files. So I renamed that document and you can find this document, webinar document with exercises on a shared folder here where it is. This is the, I have to save it, save, and it's, no. Yes, here is the document with exercises. And we can finish because I thought that we could share your screens with us with your results, but in a Zoom it's not possible. So we can proceed to questions. Here is the exercises for you. Okay, I will show it on. I will let it on the screen. You can try to finish it, and I will answer your questions from.
We have one question in chat.
Yes.
You can see.
Okay. So, is this collaboratory thing free for basic use? It will be free until upgrade to Pro. This is free for use. That strong machines are free, but the Google is the strong machines are not dedicated to you as user. If you run there some very complicated computational, very very hard computational tasks, it can sometimes be broken. So so it's mainly for the educational purposes, not for work. But it's very good, and the stability of the servers are very good. But the servers are working mainly for the paying customers and not for the free users. But if they are not if they have no tasks, they will serve to you. So Google is giving to us the servers which are without the tasks. But it's totally free. It will be free, and if you are a professional user, you will have access to much stronger servers with better stability, and you can make working tasks on it. Okay, I think that I answered that questions. So here is
maybe there is Marek, there is one question in chat. Maybe
yes, I see.
go to the chat, not to Q&A, but
yes,
to chat. And
I'm looking at Gmail. I click the file on your Google Drive, but nothing occurs. What I'm doing wrong? You have problems with this. Okay, I try to make better share of this folder. You can change the files, but you have to make copies of the files because it will be corrupted. I think, I don't know. We will see if somebody changed the file, if other people will have it changed. So you can try now, please. So only take any from the Python notebooks documents, for example, this, run it. Okay, so you can make a copy here. Save a copy in a drive. So you can make your copy in your drive. Please make this copy, and then you look where that copy was downloaded or copied. I think that Google. So save a copy of to your Google disk. You can download it from here. You don't need to click on it. You download it. You can download it. There it is. Here. Make a download to your disk, to your computer, home computer, and from home computer you will upload it to your Google disk from here. You can search that downloaded file. This is Jupyter source, and open it. It will be uploaded to your Gmail hard disk, and if you run it from there, you will be your changes will be no problem for others. So this is the first task. Second task is to run some scripts from this Python document, and any commands. It's very easy commands, basic commands, and if you don't know Python, it's very good document for you to start with Python. And Python is very important because without Python you cannot do machine learning. So you can print some text, you can make some mathematics. This is the comments, because your source code often needs to be commented to be good readable. This logic operations is used for forking the source code. If then else coding. Here is logic operations. Python understands the 0 as false and any other number as true. So 5 and 0 means that 5 true and false means false, because false and true and false are not the same. No, true and true get true, and it is true and false. So it will not be true but false, and false is 0. So from first is 0, 0. This can be 0, but this is true, and it's getting 5 because of every language has different conversion between numbers and true and false booleans, and integer numbers and floating point numbers. So Python is working such way that 5 and 5 means 5. Okay. So this is logical operations. Variables, you can see. This is simple. In this variable a, I will give this number, and I can make mathematical operations. this is example for some error. Python is not using this. You need to use 2 characters. And etc. So we need to learn Python. It's very important.
Okay, so you have probably the last chance to ask questions because we have just, I think, 7 minutes to go.
Yes.
So if you have questions, then ask now.
Please ask a question. And if you run that commands, you can change something. You are free to change anything, and sometimes you get errors. Sometimes you get different results. So it's interactive playground. So perfect. Google Colab is perfect. So in third exercise, change something and look at the results. This will be not possible. So I'll delete this example exercise. And here we have plotting examples. Here on the Google disk is plotting examples. It's very nice plots, and plot are graphical representation of data. So it's very nice. You can see the data. This data is from one package where is some example data like that on a text file, but this is in a package. And from data we get the cars data. But here is some other data. Not only about cars. We need to look at this Vega dataset web page. From that web page, that Python package was downloaded, and something more about the data. And that data we can use in our plotting command. And you can see very nicely examples how to plot, and you can play with it. So this is about basic commands. This is about plotting possibilities. And number 5, here we have machine learning example. This is this web link. So this web link is available to you. This is car price prediction. This is that file as you saw before. Car price prediction. Here is that, but you need that text data file, and this text data file is you need to download to your. This data file is here. And you need to download it to your Google disk. And when you download it to your Google disk, then to finish this last exercise, you need to run this Python cell, this Python command, to mount your Google disk to your web page, to your that document. And if that connection will be successful, if this connection will be successful, then you need to change this path to this file, and you can make it very easy. Here you can copy path. Here will be your drive. I can run it again to show you how to connect that file. You need data for your analysis. You can get it from some package with some example data, or from your files. You can make your own data files. So here will be Drive. Here is my Google Drive. After that connection, here is my Google Drive. Here is that shared folder, and here is comma separated value data file. And here I can copy path and insert it here into this command. I will show you. I delete this text. The commas are important here. I will pass the path from this copy text. So this text was copied with this button. Okay, my connection was successful, but PD is not defined because that the server was shut down, and this imports was not done. So I need to make it again. This PD is this. You don't know what it is. So because that cell was not run before. Okay, now is PD. It's pandas data structure. So I have here in df I have data, and here ahead means that show me the example from the start of the data file, and this is showing, etc. So you can see that all example. This is fifth exercise for you. Play with this machine learning example, and it can be all from me. So I can.
I think that we have a last question in
Yes.
Q&A session. So maybe you can quickly answer, like
Okay.
short answer.
Question: what you can recommend for read about prompt engineering? There is many books, many ebooks, many web pages about prompt engineering. It's really complicated. It can be really complicated, but it's slowly better theory about prompt engineering, because it's a totally new thing, 1 year and something old thing, totally new theory is coming to us, and it's really important. So I don't know I can search something, but there is plenty of this, some good book, but free web servers are the basics for prompt engineering, can be read and learn from the free web servers, no problem. So I will. Okay.
Okay, I think that we are running really out of time. Thank you, Marek, for such an exciting presentation. And I saw that there is a comment in the chat that thank you very much. This is the most interesting webinar so far from the marathon. So,
Perfect.
Marek,
I'm happy.
Thank you very much for this. And yeah, for all of you, feel free to contact us via this email. If you have any questions, please contact us. Just a reminder, You will receive the recording to your email addresses within 5 business days after this lecture. So just wait for it, please. And tomorrow you will have another lecture with Roman Babkin about the chatbot building. So we are waiting for you tomorrow, same time, same link to the Zoom. And thank you very much for your question, for your participation. Marek, once again, thank you for your excellent presentation and lecture.
Okay.
And see you all tomorrow.
Okay. Have a nice day. Bye.
Thank you very much. Have a nice day.